Hello guys, welcome to my channel. I hope you are doing well. In the previous video, in the previous class, we have discussed about the uh, theory and modes of vibration. See here, we have discussed about the theory, modes of vibration. In today's class, we are going to discuss about the instrumentation of the dispensive Fourier Transform infrared, and this is instrumentation of IR spectroscopy we will discuss. In the next video we are going to discuss about the Fourier Transfer infrared spectroscopy. In today's class we are going to discuss about the instrumentation and the sampling of IR spectroscopy. Okay, and as I said, the instrumentation is quite bit different than the UV spectroscopy, but almost the monochromators and the source of radiation are same, but the detectors are different, because here the heat is measured in IR spectroscopy by the detectors. Let's dive into the topic. Okay, firstly, the the usual optical materials, glass and quartz, the usual optical materials glass and quartz absorb strongly in the IR regions. Means the materials used in the UV regions are not used in the IR regions, because they absorb strongly, they absorb the IR radiation strongly, so that uh, thus the thus the apparatus for measuring IR spectra in is different from that of the visible and UV regions. I think so. I've understood the concept. The topic. This topic means the UV and visible materials are not used in IR regions because they absorb strongly. They absorb the light strongly. That's the point. That we'll go with the instrumentation. It contains the source of radiation, monochromators, sample cell, and sampling of system. It is a process of converting the sample in a way that we can measure the structure of the, we can determine the, or we can analyze the sample. We are converting the sample or the substance, whether it may be liquid, solid, or gas, into a favorable samples where we can analyze the sample. Okay, and we use the detectors, and in every detector there is an readout devices. Next, fifth one is readout devices. Fifth you can write. Fifth one is readout devices, you can just write it. Next, we'll go through the instrumentation. See, instrumentation is very simple, as I have showed in listed. It's also same. The source, sample, monochromators, detectors, and readout device. This is the uh, instrumentation, and you can see here the source, uh, entrance slit, dispersion system. Polychromatic light is converted into monochromatic light, and exit slit where the monochromatic light passes through the sample and the detector. And the next is readout devices. This is single beam spectrophotometer. In here we can you can see double beam spectrophotometer. Have not drawn the diagram. I'll show you the image. You are seeing, maybe, I think so. I've edited it out. Double beam spectrometer. Maybe you are seeing the image. I have drawn the diagram, but it's not accurately drawn, so that I have given the best example with this diagram. See, you can see the light of source here. Light of source can be anything. Can better I recommend you to use the tungsten, and it passes through the monochromator, where the white light is dispersed into different it dispersed into VIBGR, based upon the ranges, and it passes through passes, and the polychromatic light is converted to monochromatic light, and it falls on the upper the reference and down the sample where the light is observed. And it has two detectors where they detect the standard response and the sample response. By detecting the standard and sample response, we analyze the sample by using the standard values or the reference values, and the readings will go to the amplifier, where the readings will be amplified, and then it reaches to the recorder or the displayer. That's it. This is a simple double beam spectrometer. That's it. Next we are going to now going with the sources of radiation. Now instrumentation is done. Next we are going to with the sources of radiation. Let me adjust the camera. Sources of radiation. Next, IR spectroscopy requires a source of radiant energy for isolating narrow frequency bands. IR emitted by the source should be steady of intensity sufficient for detection and should extend over the desired wavelength. Here they are telling that it should be steady and intensity should be sufficient for detection, and it should extend over the desired wavelength. I said right, IR region, they should extend over the full IR region. The various types of detectors are used here. You can just see there are mainly 5 types. I recommend you to write the tungsten filament lamp. It is very easy. We are already discussed in the UV spectroscopy, and any one IR source is enough. You can just read out it. There is nothing to explain about it. Next, we are going with the monochromators or wavelength selectors. We have already discussed this in the UV spectroscopy. So that I said you right, in the UV spectroscopy itself. Every UV spectroscopy topic is very important, which is related to the every next topics. So that if you have not seen the UV visible spectroscopy videos, you just glance it once, and then you come back here, because I am not going to explain it twice. Next, radiants of various frequency are emitted by the radiation source. Since the sample of in IR spectroscopy absorbs at certain frequencies, desired frequencies from the radiation source should be selected, and the radiation of other frequencies should be rejected. As I already said you, see, only desired frequencies are observed by the sample. So selection the radiation source should be selected, and the radiation which are not required should be rejected. I think so. Understood the property, understood the monochromatous function. See, here we are using 2 types of monochromatous. It may be prism or grafting. The prism or grafting, you can just see the UV spectroscopy. You will just understand it better way. Next, we are going with the detectors, sample cell and sample handling. See, we do sample cell and sampling of system, because in the IR, right, in the liquid, the solid and gas are shows different values. So sample handling is very required to make the readings accurate. Infrared spectra may be obtained for gases, liquids or solids. Okay. Material consisting of sample should be transparent to the IR radiation. So the salts like NaCl, KCl are only used. Okay, I think so you have understood. It should the sample or the cuvette are made up of the NaCl or KCl, because they are transparent and they does not absorb the IR radiation. Next, sampling of sample handling of sample of same substance shows shift in absorption bands. See, if the sample substance is solid, it shows different absorption bands. If it is liquid, it shows different absorption band. If it is gas, it shows different absorption band. So sample handling is very must and should required for IR spectroscopy. As we pass from solid to gases, and hence the sample of different phases have to be treated differently in IR spectroscopy. I already explained this sentence. Next, there are mainly 4 techniques for solids, and techniques for liquids, and technique for gases. We will go through all one by one. See, there are 4 techniques: solid run in solution, mull technique, or pressed pellet technique, and solid films. I think so. Listed out all the 4. We'll go through the one by one in detail. See, firstly, dissolved solid sample. The solid sample is dissolved in non-aqueous solvent and placed Place a drop of the solution in alkaline disc, metal disc, and allow it to evaporate, leaving a thin film which is mounted on the spectrometer. See here what is happening, right? We take the solid and dissolve it in non-aqueous solvent, and we take a drop of solution uh, in alkaline metal disc. We transfer it to the alkaline metal disc where it is a disc type or vessel, we can tell, and it is allowed to evaporate, leaving a thin film. A thin film is formed after the evaporation. The thin film is mounted into the spectrometer. The different solvents, examples of solvents used are acetone, cyclohexane, and chloroform. This is the basic techniques and very important. The second technique is mull technique. In this technique, finely powdered sample plus mulling agent are mixed together to form a thick paste. It is also called as mull. Then transfer the mull or the thick paste into the mull plates. Okay, the plates are squeezed together to adjust the thickness of it. Thickness. It is then mounted to the spectrometer. See here what is happening, right? Firstly, we mix the powder, finely powdered sample, and mulling agent. We mix both, and the paste is formed. The paste is squeezed between two plates. Squeezed between two plates to adjust the thickness. Then the film or the material is transferred to the spectrometer. I think so. I've understood the topic. This topic. Next, we are going through the press pellet technique. As the name suggests that here the pellets are formed. The powdered sample is mixed with about 100 times its weight of potassium bromate in a vibrating ball mill, and the mixture is then pressed under very high pressure in a die to form a small pellets. Here the pellets are formed and the pellets are transferred to the spectrometer. Next, fourth one is solid film. As the name tells that the film is transferred to the spectrometer. Here the amorphous solids are dissolved in volatile solvents, and this solution is poured on a rock salt place like NaCl and potassium bromide. Then the solvent is evaporated by gentle heating. Then the film is formed. The film is mounted to spectrometer. Okay, I think so. I've understood, guys. Next, sampling of liquid. Liquid samples can be sandwiched between two alkaline metal discs. Example, on sodium chloride, potassium bromide, and calcium fluoride. By squeezing the liquid sample between the alkaline metal plates, they are detected. The sample cell thickness should be 0.01 to 0.05 millimeter. Next, sample handling of gases. Here gases samples are introduced. Here gas samples are introduced into a glass cell made up of NaCl. Very few organic compounds can be examined as gases. Example, 1,4 dioxane. I think so. You understood the sampling and why we require the sampling. And next, the last but not least, the detectors. The detectors used in the IR spectroscopy are thermal detectors. I already said you they are based upon the heat, generation of the heat, so that they are also called as thermal detectors. Okay, when IR radiation falls on a thermal detector, its temperature increases due to heating. The increase in the temperature produces potential difference which is proportional to the amount of radiation falls on the detector. See, the increase in temperature, as the temperature increases, there is increase in the amount of radiation falls on the thermal detector. They are directly proportional. Temperature increases, intensity of the light on the detector is increases. By this way we can calculate the sampling. This way you can analyze the sample. Mainly I'll show you the sorry guys, I don't get it. These are the 5 types of detectors. You can study any 2 types of detectors. I'm going to explain the thermocoupler and bolometer. See, there are these 2 detectors are very simple to understand. You have to just understand the diagram, that's it, and the mechanism and the constructions you can write based upon your understanding. It firstly mainly the diagram. See, it contains T1 and T2. These are measured junction where the IR radiation falls, and reference junction. Okay, measured junction and reference junction, and it is connected to by a dissimilar metal wires. These are dissimilar metal wires made up of bismuth or antimony. Okay, and these 2 wires are connected head to tail. See, head to tail, these 2 wires are connected head to tail, and it is connected to a voltmeter where the voltage or the potential change in the potential difference is measured. Okay, next we'll go with the explanation. This is the constructions. You can just directly write. It is made up of two metals like bismuth and antimony coated with metal oxide. The wires of two dissimilar metals joined head to tail. Then a difference in the temperature between the head to tail causes the current to flow. Here the principle is based upon the change in the temperature between the head and tail, as then the current flows. The change in the temperature occurs when the IR radiation falls on the measuring junction T1. I already said this is the measuring junction T1. The IR radiation falls on the T1. Okay. See, this current is proportional to the intensity of radiation, and this is also called as thermopile detector. A material should be thermally active, and these are used to uh, dispersive instruments. Response time is 30 milliseconds, and gives response for all the frequencies. See, I'll just explain the principle. As the IR radiation falls on the T1 junction, there is a change in the temperature between the two dissimilar wires between the head and tail. Then this causes the current to flow, and the current is measured, and the sample is analyzed. Next, we'll go with the bolometer. This is the diagram of the bolometer. You can just see the diagram. See, the bolometer works on the principle that the electrical resistance of a metal increases by 0.4 for every Celsius degree increase in the temperature. See, it's also same principle. It is based upon the increase in the temperature, and as the IR radiation falls on the detector. See, you can understand this by this point. The bolometer consists a thin metal conductor whose temperature changes when IR radiation falls on it. See, when the IR radiation falls on this metal conductor, there is change in temperature. The temperature change is used to measure the sample. The resistance of this conductor also changes with temperature, and the degree of change in the resistance as it measures the amount of radiation that falls on the bolometer. I think so I've understood. The here when the IR light falls on the metal wire on the uh, metal conductor, then the change in the resistance or the change in temperature is used to detect the sample. Okay, I think so I've understood the point. Next, readout devices or the recorders. The radiant energy received by the detectors is converted into measurable electrical signals and is amplified by the amplifier. Okay, the amplified signal are recorded and plotted. Its records transparency of sample as well as the function of the wave number. It just recording devices are used to record the signals from the detector, and they are used to amplify, convert electrical signals to converts the into measurable electrical signals. Okay, this is the concept behind the instrumentation and sampling. Next we are going to study about the last Fourier transfer infrared. By this we'll complete the IR spectroscopy. In next video we'll complete the IR spectroscopy. Then we'll start with the spectrofluorometry. Thank you guys for watching. See you in the next video.